Hi everyone, I'm Teacher Jonna and welcome to my Calculus 2 video tutorial. Today we will explore one of the most essential concepts in math, which is functions. In this video, we'll talk about what functions are, how to evaluate them, identify odd and even functions, and how to find an inverse function with full examples. So let's make this math journey fun and understandable. Let's go! First, let's discuss what a function is. A function is a rule or relation that assigns exactly one output for every input. In math, we often write this as f of x equals expression. For example, if we have f of x equals 2x plus 1, g of x equals sine of x, and h of x equals the square root of x, it means that we input a value of x and it gives us a value of y. Second, let's evaluate a function step by step. To evaluate a function, follow these 5 steps. Step 1. Identify the given function. Step 2. Identify the given input value of x. Step 3. Substitute the value of x into the function. Step 4. Simplify and solve step by step. Step 5. Write the final answer. So now, let's apply these steps to an equation. For example, f of x equals 2x squared minus 3x plus 1, and we are finding f of 2. So just like what I've said earlier in step number 3, we need to substitute the value of x into the function. So it becomes f of 2 equals 2 times 2 squared minus 3 times 2 plus 1. And now, we can simplify and solve it step by step. So let's start with the exponent. So 2 times 2 equals 4. Next, we can multiply and simplify it. So 2 times 4 minus 3 times 2 plus 1. So it becomes 8 minus 6 plus 1. And our final answer is f of 2 equals 3. Easy, right? Okay, now, let's talk about the odd and even functions. So a function is even if f of negative x equals f of x. This means that if we replace x with negative x, it gives the same output as the original function. For example, the given function is f of x equals 5x squared minus 4. To test for symmetry, we substitute negative x into the function, giving us f of negative x equals 5 times negative x squared minus 4. Since squaring a negative number results in a positive value, negative x squared becomes x squared. So the expression simplifies to f of negative x equals 5x squared minus 4. Now, we compare this with the original function. Again, f of x equals 5x squared minus 4, and we see that they are exactly the same because f of negative x equals f of x. This confirms that the function is even. So now, let's discuss how to identify if the function is odd. So a function is odd if f of negative x equals negative f of x. This means that if we replace x with negative x, gives the opposite of the original output. For example, the given is f of x equals 5x cubed minus 7x. Next, we substitute negative x into the function, giving us f of negative x equals 5 times negative x cubed minus 7 times negative x. Now, simplify. Since the cube of a negative number stays negative, so we get f of negative x equals 5 times negative x cubed plus 7x. This simplifies f of negative x equals negative 5x cubed plus 7x. So factoring the negative sign, we have f of negative x equals negative open parenthesis 5x cubed minus 7x close parenthesis. That expression matches the negative of the original function, which is read as f of negative x equals negative f of x. Therefore, the function is odd. Lastly, let's find the inverse of a function. So an inverse function reverses the effect of the original function. In simple terms, if y equals f of x, then the inverse is x equals f inverse of y. To find the inverse of the function, we start with the given equation, read as y equals 4x plus 3. And our goal is to find the inverse function. So we need to solve for x in terms of y. First, we subtract 3 from both sides. This gives us y minus 3 equals 4x. Next, we divide both sides by 4 to isolate x, resulting in x equals y minus 3 over 4. Since we now have x in terms of y, we can express the inverse function. So the inverse function is read as f inverse of y equals y minus 3 over 4. This shows that the inverse of the original function, meaning the inverse function and thus the operation of the original function. And that's it. Remember, understanding functions help you understand the core of calculus, so keep practicing. Once again, I'm Jan Suzanne Bendaño from BS Ed Math 2, and I hope this video made you say, now I finally get it.